Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual service for your next project. We are also sponsored by Sentry this week. Stop hoping your users will report bugs. Sentry's real-time tracking gives you insight into production deployments and information to reproduce and fix crashes. Check them out at getsentry.com and use the code podcastinit at sign-up to get a $50 credit. You can also visit our site to subscribe to our show, sign up for our newsletter, read the show notes, and get in touch at podcastinit.com. And to help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers. You can also join our community forum at discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, propose show ideas, and follow up with past guests. Your hosts as usual are Tobias, Macey, and Patti, and today we're interviewing David Fisher and Greg Price about Mypy, a library for adding optional static types to your Python code. So could you guys introduce yourselves? How about you go first, David?
Sure. So, hi everyone, I'm David. I've been working at Dropbox for the past couple of years and on Mypy itself since the beginning of this one.
And Greg, how about you?
I'm Greg. I also work at Dropbox and have been doing Python for a long time and long wished that it had types, and I'm very happy that we're now granting my wish.
So how were you folks introduced to Python?
So I was introduced to Python it was part of a low-level C class my freshman year of college. My TA at the time held just sort of a special section on Python, just a sort of a bonus thing. It wasn't really needed for the class at all, but it was just something that he liked a lot. And I had my mind blown at the time by the fact that you could use negative indices to index from the back of arrays. I just thought that was the coolest idea ever. I really liked what I saw in the sort of small, taste of it that he showed us. And so I started doing some side projects in it. Nothing too exciting, just playing around with it. And that sort of started my love for it, I would say.
And how about you, Greg?
Sure. So when I was in high school, actually used to do computing contests, and my brother did too. And one year when he won one of these contests, the prize, as usual, was you got to pick a book. And the book he picked was one on this language actually neither of us had heard of before called Python. And he got really into it, and that's where I got into it.
Great. And can you guys explain a bit about what Mypy is and some of its origin story?
Yeah, so the good news here, we're telling everybody at PyCon and everybody we can, is that Python now has static types. They're optional. They have no effect at runtime, but they're really good for making a code base easier to understand. And that's why we're really excited about them, why both David and I are, and why Dropbox is excited about them and actually sponsoring full-time work on it. So the static types are the sort of center of the story, and Mypy is the type checker, which is a key part of making that whole thing work. And so where we come from in really being interested in static types is about understanding a code base, understanding a Python code base, especially one that's large that has many people working in it. So there's this little story that I've lived out many more times than I would like, where I'm trying to understand some little piece of code. And it's just a couple of lines, maybe, just a handful of lines. And I want to know what it does. And it calls some method on a thing. Great. What method is that? I want to go and look up that method so I can find out what it does, either the documentation, if there is such a thing, or the implementation. And I can search the code base for methods by that name, but there might be a lot of methods by that name. There could be hundreds in a giant code base like Dropbox's, or there could even just be two, and that's enough to potentially be a pain. And the question of which method it actually is it's called is a question of what type the thing is that you're calling it on. And the same story occurs for all kinds of questions you might want to answer about how some piece of code works. You have to know what types the things are that it's operating on. And traditionally in a Python code base, what you end up doing is what type is this thing? Well, it was passed in as a parameter to this function. Great. I go and search for where this function is called, figure out what types, again, the arguments are that are being passed there. And now it's the same problem recursively. And I go and maybe search for, maybe it's obvious at that spot, or maybe I have to go and search for the callers. And I end up searching through many thousands of lines of code and reading through many thousands of lines of code potentially, just to understand what one line of code was doing. And that's the thing that I hope to never do again. And if only when I or whoever else was writing that code in the first place, we had just at the top of the function written down one line saying what the types are supposed to be of the arguments. That would terminate that whole search right at the start. And it makes it much, much faster to figure out what this code is doing. And that's now what we're doing, what many people are doing across Dropbox's code base, many people are doing across a number of open source code bases and elsewhere. And you put you write down the types at the top of the function. You write down the types wherever it's not obvious, and that's the static types. And the crucial part, the part that like is new effectively, that's needed in order to make this all work, is you always could have written down the types in a comment or a doc string, right? And people even had sort of conventions for how to write them down in doc strings. The trouble is, and I think probably anybody that spends much time in a code base that a lot of people worked on over time sees this play out. Comments become lies. Somebody writes down a comment, and it might be truthful at the time, and then the code changes, and somebody changing the code doesn't see the comment, doesn't think to update it, the comment becomes no longer true. And once you see that happen a few times, you realize you can't rely on the comments, and so you end up actually really doing the same work of understanding the code because you can't trust the comment to tell you the answer. And so the critical thing is that you write it down in a way that a machine can actually check is not a lie. And that machine check is the type checker. And Mypy is a type checker.
And as for the origin story, Mypy was started, I guess, about 4 years ago now by Yuka Letosalo in 2012 as part of his PhD work. And it was originally a sort of a custom language, which is how it got the name, sort of a language that was very similar to Python, but not quite. But then he ended up meeting Guido at PyCon in 2013, and Guido convinced him to just do this kind of type checker, to switch this from a custom language to just type checking pure Python. And it sort of had some work on and off by various contributors in the years since, but at the beginning of this year, we really started working on it full time. Me, Greg, Guido, Reed Barton, mainly, and a few others.
And Yuka also putting a good bit of time into it as well.
Going back to your point about searching through a large code base of trying to figure out where different things are coming from, to some extent the origin of at least methods anyway is somewhat alleviated by the strong focus on namespacing in Python, but it's definitely a lot easier to have that information very local to the function definition, because then you don't have to go looking back at the top of the file, which could be many thousands of lines back, and then trying to remember, okay, where was I when I first started this search? So,
and in any event, I don't really agree actually that namespaces, by namespaces, I think maybe you mean like module names and package names, sort of hierarchical names of modules.
Correct.
That works great for like invoking top-level functions that would find the top level of some module, because you went and imported them from that module, or you imported the module and referred to the module in the code either way. But if instead you invoke a method on something, you had a class somewhere that defined a method, and you may have had several unrelated classes that define methods of the same name, because like popular names are popular. In the Dropbox code base, the name validate, great word, lots of people choose it. There are well over 100 different methods named to validate. And a smaller code base, there might be 2 or 3, but that's enough to be uncertain what something is doing until you go and work out like which of those it actually is. And the question of which it is precisely what is the type of the thing that you're invoking the method on. And you don't you just have this thing that like was a parameter of the function or what you got from an attribute on somewhere else. And you don't have a module name anywhere. The only way to work out what it is to actually figure out the type.
Yeah, that's definitely true, where it's really only useful for top-level functions. So it definitely makes it clear for why Mypy is useful for existing and particularly large projects. What about for smaller projects or projects that are just getting started? What would lead somebody to want to use them, particularly, for instance, where the entire program exists in a single file?
Well, I think there are a few reasons that you might want to do that. The first is I personally find types to be a pretty helpful way to structure my thinking about my own code as I'm writing it. It just kind of lends some clarity to what I'm writing down. And if I just start by writing the types at the top of a function, it'll be a little bit easier for me to write the function body a lot of the time. Also, Mypy will, it's a type checker. It's not just this like annotation system. So it will catch a pretty decent variety of errors, which I think is pretty nice. And also, if you, even with just one file of code, if you come back to it like 2 or 3 weeks later, you may still kind of have this moment, you won't have as big a search to do, but you may still have a moment of like, all right, what is this function doing? And then you kind of got to dig and figure it out a little bit. Whereas if it had types, it may be very immediately obvious.
So can you explain a bit more in detail what the actual compilation step looks like, what kind of operations it's doing under the covers?
Sure. So it's not actually compilation per se. It's more like a linter on steroids, but there's kind of several stages that the code moves through. First, we have to parse it all, obviously, and we do this with this typed.ast module that we've created. We wanted something that would be very fast, but also very fast, conform exactly to like the Python language spec and also be able to parse type comments. And so we kind of wanted to use like the Python built-in AST module, but that doesn't parse comments at all. The benefit of AST obviously being that it is very fast and corresponds exactly to Python because it's the module that CPython uses when it interprets something. So we actually forked the AST module from both Python 2.7 and Python 3.5 and made them compile on Python 3 and added in the ability to parse type comments. And so now we can parse both Python 2 and Python 3 from Python 3, which Mypy is written in, and get those type comments out. So our first stage, we parse, we get a Python AST, and then we kind of put it through this semantic analysis step. Basically, it's figuring out what refers to what. So if you have some x in the body of a function, you figure out, okay, this is actually refers to the x that is passed in as an argument. Or if you have some class definition, you figure out, oh, okay, that's imported from such and such a module at the top of the file. And so we kind of make all those connections in this next pass. And then sort of finally, we have like a type checking pass where we go through the code bit by bit and determine what types kind of every different expression has, and at the same time check that there are no errors when things are being used. So kind of an example from the type checking phase might be something like, okay, we see as we've recursed down into a function, we see, okay, this is an integer literal, so now we know it has type int, and then we can propagate that out. Or kind of in a more complicated case, we see like, this is a function call, so let's use the semantic analysis phase information to figure out what function it refers to exactly. And now we know what type it's expecting to take as arguments, and so we can kind of recursively run this type check on all the arguments and figure out if those, make sure those types are compatible and print an error if they're not.
I have a thought actually I'll add on the benefits for like small pieces of code, which is amplifying the bit where one of the functions of it is to find errors that are in your code. One of the more frustrating things that you can have happen when you write like some little script is often you write maybe a small enough code, just dozens or hundreds of lines of code for a script you're going to run, and you're going to go and run it on some data, right? Or it's going to go and like fetch some stuff from the web or something. It's going to do a bunch of processing. And an experience that certainly I've had more times than I would like is you have the script, it's doing its work, and right at the very end, it blows up with some stupid bug. And all of that like intermediate work that is done is just lost as the script fails. It's blowing up with like an attribute error because you mistyped something, or blowing up with some error because you have a none somewhere, which was because you basically made a type error. All of those classes of errors you're really most especially likely to have in this code that you're like, it's in the script you're running basically the first time, because that's sort of how script development often is for processing data and so on, are the kinds that Mypy is especially likely to find for you. And so it's been a little while since I wrote a like complicated script, but definitely the next time I would be doing so, I would very much want to be writing types on it from the beginning so that I can have that benefit, and so I can never have that experience that blows up on a stupid, dumb bug after doing much work and destroys all the work.
Yeah, I've definitely run into situations like that because I've spent a fair bit of my career doing various data munging, and that's particularly painful when the data that you're operating with or the outputs that you're dealing with are not idempotent.
Mm-hmm. Right. Yeah. Then it's actually dangerous, right?
Yeah.
So what are the biggest technical challenges in implementing Mypy?
So I'd say the design decisions are actually the hardest part, probably because Python Python seems simple from a high level, and as a user, most of the time it is. But when you look at kind of the nitty gritty of the semantics, it's actually really very complicated. And there's a lot of very dynamic things going on. And so kind of figuring out where the right place is to provide structure on this dynamic behavior is very difficult because we want to support as much of the full Python semantics as possible. Like, we don't want to say, hey, we're making this really restricted subset of Python that you can type. We want to try to type as much of the language as we can, but you still have to carve out some boundaries. If you're going to be calling getAttr with some string that comes from somewhere, like, hey, we're not going to be able to check that attribute actually exists. That's, potentially just impossible. And so figuring out where those boundaries lie and like what to do about various edge cases has been quite a difficult task, I would say.
Yeah, and I imagine that it's probably difficult to prevent it from being overly opinionated and thereby restricting the types of things people can do with Mypy.
There are always going to be valid programs that won't type check. But what we're aiming for is, if you have to convert your program to some form that type checks, the type checking form should be clearer anyway. Like, hopefully, in converting it to type check, you're just having to like remove code smells or doing kind of weird things that maybe you shouldn't have been doing in the first place. And so that's the main place where we feel good about making the trade-off of saying, hey, like, we're not going to support this right now.
Yeah.
Because
that's the thing we very much see people doing. Both people in some parts of Dropbox working with some of the code that's especially like been around for a long time and may have the best choices, or also just other people I've seen adopting it outside. They see some code, they want to put types on it, and say, well, we don't really support that pattern, and they end up saying, oh, well, I was actually looking for an excuse to get rid of that anyway, because now is the time to do that. So when we hear that, we're happy. We're like, everybody's happy. We don't really mind that there had to be some change to the code to type check. But we, in general, want to minimize the changes that have to be made to the code base in order to put types on it. And we want to maximize the amount of the code that can end up with types on it with a minimum of change to the code. It'll always be okay to have some parts of the code base just not have types on them. That'll always be like totally fine. But we want to be able to use types as much as possible to get the benefit of them as much of the code base as possible without having to make. And so that's doing that while maximizing the benefits that they do give by giving useful structure to the code is the trade-off, the boundary that always has to be found.
Yeah, and there's also a certain critical mass whereby you have a certain percentage of your code that has type annotations, and those types can then propagate out throughout the rest of the code base that doesn't necessarily have the annotations already labeled, but you can provide those inferences based on how those changes are propagating throughout the overall code.
Well, it actually turns out that we shy away from type inference for the most part. And this is kind of a purposeful decision because we want people to be able to roll out their types to code bases gradually. And that's partly because we have a very large code base that we're rolling out types to gradually. But, say a couple of years ago, nobody had types in their code at all. And so every use of this is going to be a gradual rollout or unless you're starting a new project. And part of that is being very permissive about code that doesn't have type annotations in it. And so we sort of let you gradually expand your area of annotated code, and everywhere that's annotated, we check actually type checks. But we try not to reach, or in fact, we're pretty careful to not reach into unannotated code to yell at you about errors there, because otherwise, if you have like 100,000 line code base plus, and you start to you add types to one file and you run Mypy on it the first time, you'd get just a huge deluge of errors, and you'd be completely overwhelmed, and you wouldn't even want to get started. And so this lets you actually roll it out in a file by file way and make things better slowly and catch. And even if a lot of those are legitimate errors, or legitimate bugs that may be caught, no one can deal with those things if they get them all at once, basically.
Although that's actually an option people have. And people do actually choose different strategies in this. Because, as David said, when it does go and analyze all the code, even without annotations, it often finds quite real bugs. A strategy that some users take, for example, one of the open source projects using is Zulip, a chat system in Python. They've taken the choice, we only have a few tens of thousands of lines of code. I forget just how much, less than 100,000. And we like finding bugs. So we're going to actually pass this flag to Mypy, which says, actually go and check all the function definitions, even the ones that don't have annotations on them. And when you pass that flag, it will not make a lot of assumptions about that code, but there are some things it totally will be able to find. And so they went through and had to go and systematically actually fix a good number of bugs to make it clean with that. Mostly small bugs because they had good tests. If you had a less comprehensive test suite, you'd probably find more bugs. Fix bugs and also make some things just where Mypy was required the code to be structured in certain ways in a few places. And then they got it to be totally clean with that option. And now they have that option when they run in CI, and every change you make to the code base, it has to remain clean and not introduce any bugs that finds. That's sort of a strategy choice that you have to make in adopting on a code base. So for the entire Dropbox code base, there's millions of lines of code. That would, for all the reasons David just said, be a strategy that would not work. It's really important that you be able to adopt it gradually and not deal today with fixing all the bugs in the entire code base. And so that's why that's the default.
Yeah, it's definitely important to be able to gradually ramp up the level of aggression on checkers like that. And it is useful, too, where even if you're not in your day-to-day running it across your entire code base, being able to occasionally just say, okay, how far away are we from eliminating all these issues, just as a periodic progress report?
Yeah, I think it can be. I think the strategy for adopting this on a given code base, I think always crucially has to involve you put it in your CI system. You run it the same way as you run your tests. And if hopefully you run your tests every commit you make, or most of your tests, Mypy is quite fast compared to any decent test suite. You run Mypy every commit you make, and you don't let a commit go in that breaks the Mypy build. And so a crucial part of making that work well is that it's actually quite easy to get it running cleanly on your whole code base, because by default it will be very conservative and not making a lot of checks. It will not by default go and like try to find all kinds of bugs that might be there somewhere. But it will start by just making very few assumptions, checking very few things, and as you go and add annotations, it will check more and more. And so you can start by having it like totally clean results because it's not checking very much yet. And you start adding more annotations, it checks more and more, and you maintain the invariant that is always totally clean.
And the reason that that's really a really important thing to maintain is because that is what lets you actually trust the type annotations. And if you don't keep up on that and the type annotations just degrade to be like doc strings, then there's kind of the problem we mentioned before, is that you can't trust this and you have to go back to your search.
Another thing actually that right up there that's maybe worth discussing, you mentioned type inference. And there's different approaches people sometimes take to type checking and to like type systems in a statically typed code base, ranging in one style of programming, which there are some projects trying to do this in Python, and there are languages where this is the aesthetic. You write virtually no type annotations anywhere, and you just have you're really proud of your type checker being very smart and being able to infer how the types flow everywhere. And that is a thing that can work for some purposes, but actually, even if you have like a really, really smart type checker that is able to do that successfully, I think it actually doesn't serve the main purpose that we are really excited about types for, which is to better understand the code. Because for that purpose, the crucial part actually is that you do write down the types. And so the balance we've chosen, which is also the balance that we've seen work well in some other languages, even when you have the option of really not writing very many, is at the top of every function, you write down the types. You write them down. Partly just because it helps out the type checker, makes it easier for us to make the type checker like fast, but partly because that's really actually the point, is to be written there in the source code for the benefit of the next reader. You write it down at the top of every function. You also write it down in other places where it might not be obvious. Obvious to a human reader, also obvious perhaps to the type checker. And so the consequence is that it's there, it's written, it's quite lightweight, just one line at the top of a function. It's not like in some languages where like almost every line you maybe have to write some types. But a line at the top of the function and a few other places, and so it serves this purpose very well of telling the reader what's going on. And then the type checker has a sort of lighter weight level of type inference where within a function, it will work out, we started with these parameters, you went and did some like straightforward operations on them. I know what types those produce. I know what type you did here, et cetera, et cetera. And it can sort of follow the thread of how the types evolve through the function.
So are there any limitations imposed by the syntax or semantics of Python that prevented you from implementing any features or syntax that you would have liked to include in Mypy?
One of the things that you have to do right now, even in Python 3, which has sort of a nice function annotation syntax, is if you're trying to annotate a variable, you have to put that annotation in a comment. And we think that at some point down the line, we would like to find a syntax for variable definitions that doesn't require you to use comments, but right now you do.
Yeah. And I think you mentioned another question. You heard Guido say on stage at PyCon that he would like in Python 3.6 or 3.7 to actually have that kind of syntax. This might actually be a good point also to emphasize Mypy works great on Python 2 as well as Python 3. That's very important to us at Dropbox because Dropbox's code base is almost entirely Python 2. And so certainly one consequence is Python 2 has no built-in syntax for any kind of type annotation, as Python 3 does. And so a consequence is that you just have to put the annotations in a comment. And if you look at PEP 484, you'll see there's a specification there for precisely what that syntax should look like, which basically we developed and we standardized in PEP 484, discussing with people elsewhere in the community, because Python 2 support was very important to us. And it's in a comment, makes it look a little ugly, but it works fine.
And another approach, at least in the typing module, was to introduce the concept of stub files. Does Mypy support those as well for being able to add those type annotations to Python 2 code as well as an alternative to the inline comments?
So the short answer is yes, with a small complication. The thing about stub files is, for us, the purpose. So the really crucial step for our purpose is actually to write down what the types are right there in the source code. So when you're going and reading the source code, you have the types right there as the reader. And so if instead you go and put them in a file off to the side, it doesn't really serve that purpose. And so where subfiles are very useful, even in our strategy, is when you have a third-party library that you don't control, that you don't want to start like patching. Stub files are very useful as a way of being able to write the types separate from that in a separate file you control more easily. And actually also for the standard library, that's how you do it. There's a shared repository that is sort of bundled with Mypy that is also used by other tools that understand PEP 484 for writing down types for the standard library and for third-party libraries that are cool with it, which most of them are.
And that repository is called typeshed.
Yeah. So you can use stub files for code that's really your own. It, as I said, doesn't really serve what we see as the main purpose. And there's a small wrinkle, which is that if you do that, I believe Mypy won't actually go and type check it against. It won't type check that file that you have the stub file next to. Partly that's because that's just not a workflow that makes sense to us. Partly it's because the main use case for stub files for us is, again, these third-party libraries and so on, where it wouldn't make sense to try to type check them, because what are you going to do about the errors? And in fact, actually related to that, extension modules. So even actually for your own code, if you have an extension module you've written, that's C code. It's not Python. There isn't really a sensible way to type check that, or maybe there could be, but that would be a whole project of its own to type check like an extension module. And so for that, again, you write a stub file, which is then very handy for your code that uses that extension module. But we don't attempt to type check the extension module against the stubs you written.
Type theory is a very large and complex problem domain. Can you explain a bit where Mypy falls in that space and what the biggest influences are on how the particular typing syntax and semantics came into play?
Yeah, so I think the most kind of important thing about Mypy from this perspective is that it's a gradual type system. And I think we've already talked about this a reasonable amount, how this is something that lets you roll it out slowly over a code base over time. And this is actually something that we took mainly from somewhat recent academic work that came about in the last few years. In particular, this kind of idea of an any type, which is basically like an escape hatch from the type system. But the formalism of it is it's like treated a bit separately from the rest of all other types. So that was a really crucial idea. Kind of, I guess, in terms of, say, expressiveness, I would say it sort of lies, it's more expressive than Java overall, and is less expressive than, say, like Haskell or Scala. I would say closer to Java than those.
But you write a lot less than Java.
But yeah, yeah. And in terms of the languages that influenced it, honestly, we tried to keep it just as Pythonic as possible. So we didn't look. I mean, on the team we have a pretty wide swath of languages that we're familiar with by way of background, but we didn't look to those languages too strongly in our design of like PEP44 and Mypy stuff, because we really wanted to make it feel Pythonic and not at all like people were having to write Java in Python or anything like that.
As David said, like by far the major source of the semantics of the type system is Python itself. And the main sort of ideas that come to mind that are not sort of already there in the Python type system are the any type, which, as David explained, comes actually really not from any other language in particular, but comes from some academic work of recent years. And generics. Generics are a great idea. At this point, they're decades old, and they've become a really widespread idea. There's no like one language you can really attribute it to. They're so widespread that if you look around at new languages that come out, like Swift, of course it has generics. That's just sort of table stakes for a good new language in this decade. And so we have those. And I think they sort of fit very naturally in the way that people think about Python code in the past.
And another interesting type idea that is implemented in Mypy and in the typing module is the idea of the union type for being able to accept a range of different possible types based on how you're using the function.
Yeah, and that's not something that you see in that many other languages. I mean, it's sort of like a sum type,
but different.
But also different, yeah. And that one we mainly came about because that's something that's a pretty common idiom in Python, and so we just support it.
Yeah, I think it really goes in the category of stuff that came from how Python code is written. And there is like a formalism for that, which people have had over in type theory for a while, and that's of course helpful in being able to write a type checker that understands it. But as a feature really comes from Python proper.
Yeah, because a lot of other languages where you would use a function in that manner would generally implement it would implement the function lookup as a function overload, and so that would negate the need for any sort of a union type. But because of how Python doesn't have function overloading, and instead you add that logic in the actual function body, that's where the union type would become necessary.
Right.
Yeah, often.
And it turns out actually that sometimes you want to express overload style things. Like let's say you have if you have a function whose return type depends on which element of the union you take in, you can actually sort of write this out. You can say, well, if I give it an int, then it'll give me back a string, and if I give it a list of ints, then it'll give me back a list of strings, for example. And this is only at the type level. Like we're not providing any multiple dispatch machinery for you, but
yeah. So another way of saying this, there actually is a concept that's called overload that is in PEP484. And it's there because, actually, especially in the standard library, there's a large number of functions that have this like somewhat complicated behavior where you could have written it to some degree with a union. You could say, well, it takes this argument as a union of like either this or that. But to really describe the behavior precisely, you actually want to say, you want to sort of pretend as if it's several different functions with the different types. And as David says, like the real way it's actually implemented at runtime is just, no change. There's never any runtime change with all of the Mypy stuff. But at a sort of conceptual level to understand what's happening at a type level, it's helpful to describe it as if it were an overload. And so that's a common thing to do, especially in the standard library. And so we do support that as a way of describing the type of something.
So can you talk a bit about user-defined types as implemented in Mypy?
Yeah, so this is a question that we actually kind of get asked a lot, but it turns out there's very little difference between user-defined types and built-in types in Mypy. In fact, actually, or pretty much all of the built-in types are defined in a stub file that Mypy reads in just like any other file you would write.
Yeah, in fact, all of them are there. There's a handful of very special behaviors for a handful of built-in types that have some like special case support in Mypy. The great majority of everything you would say about a built-in type is said exactly the same way that you would say it about a type you write yourself.
Yeah, it's basically just for types that you actually literally can't write down definition-wise. Like you can't use true as a variable name in Python 3. This is something that is fixed from Python 2, and that means that you can't kind of write it down on the left-hand side of an equal sign in the stub file. And so that is why that's why it's a special case built in. But aside from that, everything is, there's no magic going on behind the scenes for the most part.
And is that largely due to the fact that the type module in Python is sort of the basis for all other types, including custom classes?
Yeah, like it probably falls out of the fact that in Python, none of the built-in classes do anything too especially magical. I mean, okay, so there's maybe they're actually implemented in C, but the way they behave is just like any other Python class. And so that means that we can treat everything pretty much the same here.
I noticed in the documentation how you had special casing, a special place, lists and dicts of string or int versus any other type.
It's possible you're seeing type aliases, actually, where you can give a name to say, like if you have a list of, it's a kind of simple type, but if you have like a list of string and you use everywhere, you could call it like, I don't know, maybe there'd be some more specific name, but you could call it like string list, and then sort of say just like string list equals list of string, and then use string list everywhere instead. And this is more useful if you have, what you really have is like a list of tuples of string and int, and the third argument of the tuple is like a dict of this and that and da-da-da, right? And so you have this complex big nested type, and you can just assign it, you can just make a type alias that refers to it and use that everywhere instead.
Maybe in fact a thing worth just backing up and saying explicitly is we do support, and very glad that we do, saying, for example, not only that this function, the types of its arguments are supposed to be, this argument is an int, this argument is a string. You can say this argument is a list of ints. You could say it's a list of whatever, but more often actually what you want to say is a list of ints. It's a list of strings. It's a list of this class over there that I'd find. It's a list of any type, really, you can put there. In fact, most often when you write that a function takes a list as an argument, you're going to want to say what types the elements are supposed to be. And same thing with a dict, you're going to say what types the key and the value are supposed to be. And so Mypy gives you the ability to do that. That's what we call generics, much like many other languages, the concept of generics.
Yeah, and we also have this kind of cool thing in addition called type variables that let you define more complex relationships between arguments and other arguments, or arguments and return values. So, for example, you could have a function that takes in a set of something and returns just an element from that set. And Mypy would know if you pass in like a set of ints, then the function returns an int. And if you pass in a set of strings, it returns a string, etc.
And that sounds like a use case where you could compose some of the different types where, for instance, if you had a list that can and most likely will include both strings and ints, you would do a list where the type is a union of string and int.
Yeah,
right. Mm-hmm.
Absolutely.
So how has the inclusion of the typing module in the standard library influenced the evolution of Mypy?
My understanding is that the inclusion of the typing module in the Python standard library was kind of it was a helpful way to make sure that PEP 484 actually standardized at some point. I think there were, it makes sense. There's a lot of opinions around what types would look like and what they could look like. And at some point, everyone needed to come to a consensus, and so people could start really building off of it. And I think saying, okay, typing is going to be included in 3.5, we better figure this out by then, really helped the standardization actually complete. And so for that, I think it was pretty useful. In some other ways, it's actually a little bit unfortunate in that because typing is part of the standard library, we can't add new things to it very quickly. And so a recent example was we wanted to be able to refer to kind of the type of a class, not just the type of an instance of a class. And that required adding a new thing, which was type with a capital T to typing. And that meant that we had to wait for 5.3.2 to come out before releasing the new version of the typing module and being able to properly support that feature. I guess in general, actually kind of zooming out a little bit, Mypy and like PEP44, et cetera, have sort of both co-evolved. PEP44 was kind of strongly influenced by the existence of Mypy, and seeing what sort of things work in practice is pretty important for determining, what the standards should be. At the same time, it's not just Mypy striking out on its own and being like, oh yeah, we did this thing, now we're going to get it standardized. No, I guess that actually has a pretty big effect on Mypy. When we're considering a feature, we usually kind of raise it up to the more general typing community and say, hey, like, we're thinking of doing this. What are other people's thoughts? What form should it take? And this and that. And so there's often quite a good amount of discussion before we implement things in Mypy.
And I'll say also one thing that I'm very happy about with respect to PEP44 and the typing module is that it is a standard, and one that is really a working one that other people implement. And so when you write down these type annotations that people can read and that the Mypy type checker will check for you, they're also understandable to PyCharm, so that it can give you its IDE features when you're in some other part of the code base that knows like exactly what's going on with this type because you've written down type annotations. And they're understandable to other tools people are writing for analyzing Python code, including PyType, which is a project from Google, including SEML, which is a code analysis tool. And in general, things that people write that want to analyze Python code, there's this standard, and people are picking it up and are implementing it. And so you write down the types once in the standard way, and they're useful to every tool that wants to understand the Python code. And that's really powerful.
Yeah, I think that by sort of shoehorning the typing module into Python 3.5, it was a good way for Guido to force the hand of anyone who had any sort of opinion, because it's all too easy for a discussion, particularly about types, to get mired down in just academic discourse and never really end up going anywhere in particular. But by giving a deadline, it forced people to really voice their opinions, and if they had any strong opposition, to make that known.
Sure.
So that they could have their way.
And all the people that were like really most invested in making this good, like, came to the table. We had very useful discussions, and continue to do so with especially the PyCharm folks who were very keen on this, and that's certainly made it better.
I think that's one of the aspects of Python and its community that really, really shines, right? In some other language communities, that would have never happened. There would be 15 different incompatible versions of type annotations, and everybody would insist to the last that their way is superior, and the language would never get a standard, and ultimately it would never gain widespread adoption. And this is proving that there are advantages to having this sort of like, this is the way we're going to do it. Okay, now let's move forward.
And I think the other piece of brilliance there too is that just because the typing module is present doesn't preclude any other particular syntax, because function annotations can still be interpreted however you want depending on what tool you're leveraging to analyze them.
Yeah, you still have the opt-out. That's right.
Mm-hmm. Although technically they are specified now. PEP44 does say, unless you explicitly opt out, function annotations are supposed to have this particular meaning. Now, nothing.
Yeah, but you have a way to opt out.
Yeah.
You also don't have to run a type checker.
Yeah, and also, Python itself doesn't really do very much with them at all, and so you can totally have them, so long as they're valid Python expressions, you can still have them be whatever you want, and you're not practically going to run into any trouble. Although probably I wouldn't advise that because it's now, against the language standard. But
yeah.
So, did the inclusion of multiple inheritance add any implementation complexity to Mypy?
Yeah, some. I think, like every language that has multiple inheritance, it makes things more complex. Python is no exception. Back many years ago when that was added to Python, MROs, the method resolution order, was a good idea. That makes it simpler, but it's still complicated. It's a thing that we, like anything that's working on Python code, have to understand and deal with.
Are you guys aware of any formal studies that have been performed to research the ergonomics or efficiency gains of static or gradual type systems in programming language communities?
Yeah, this is sort of a funny area. There's, for decades, I think, been a sort of line of research in academia on this. I think it's always been a tough subject to research in an academic way because, like, the reality of how a system like this that makes the code easier to understand is beneficial is something that the reality that doesn't show up in a few hours, in your first few hours, like working with a language that was just made up. And the real benefits come in your second week of using it a lot. which is perfectly great for like a programming language or API or systems about it, which people, you learn a thing and you work on it for years. But it makes it very hard to do a study in the standard like academic way. So what I think is, and so people do them, but I think it's hard to draw much conclusion from them most of the time.
And I think cross-language comparisons are actually in general pretty difficult. There's a study that I've seen a number of times, kind of mentioned reasonably frequently actually, that says, oh, there isn't much benefit from static typing, but the way that they've drawn that conclusion is they're like, well, we looked at like C and C++ and Java, and oh wow, on average those are more verbose and have more, or have like a similar amount of bugs to Python and Ruby. Wow. It's like, well, wait a second, that's not the static types. Like that's
there's a lot.
You really can't make that comparison, and
there's
so So I think that there's also some pretty unfortunate studies that are out there.
And there are other studies that conclude that it totally is beneficial, but even those, I think it's hard for them to really do it in the usual academic fashion. What I do think is really quite informative is you can introduce a feature like this. One, before we invested all this time, like we knew from our own experience of like many other engineers we talked to, we respected, that it seemed like this would be really valuable. And then we did sort of build it and make it real, starting just the beginning of this year, really, make it a practical thing you could use on a large code base. And we've had more and more people, especially Dropbox originally, and now people outside as well, coming to use it. And so just actually like 3 months, 2 months even after that really began, we went and did a little survey here at Dropbox of people that had started using types and asked them what they thought. And made it like an anonymous survey. We didn't even know who was making which answers. And people were overwhelmingly very glad that they had done it. And overwhelmingly said that it made the code easier to read, made the code easier to understand, made them more productive working in it, and just made the code better. It was even more positive than we hoped for. And so that, I think, that's a very real kind of evidence that people with a wide range of background, people who've spent a lot of time writing code, people who spend a lot of time working in the very same code bases that they're now adopting types in, say, yeah, this makes me a lot more productive, makes me a lot happier, makes the code better. And I think that those same views are what's driving more and more people at Dropbox to use it, and also as people try it outside to keep using it and adopt it more widely on their code.
Yeah, I mean, here at Dropbox, we're not going out and annotating large swaths of code ourselves. We're building the tool, and people are coming to us basically being like, hey, I'm excited to start. When can I start using this in my code? What do I need to do to get started? And adoption is really just taking off without us having to go and do the annotation work ourselves.
Yeah, and like one person on a team will start using it, and they'll like go and like show it to all their teammates and like teach them how to use it and get them using it, and more. And then everybody on the team will be using it and will be coming and asking us questions and saying, hey, like, can you support this feature? Or, hey, like, here's this pull request to fix like a bug they found, or like to add a feature I wanted, et cetera. And so that's very, very encouraging, very satisfying.
Yeah, it would be interesting to see some more formal academic studies being done to compare usage of programming languages that both optionally have static type systems or can also be used in a more dynamic manner, to have those types of comparisons. So Python with the addition of Mypy, and then also JavaScript with the addition of TypeScript, for instance.
Yeah, if somebody can do a study that like really is persuasive and having good evidence, that'd be great. I think it is really hard to do in the standard academic forms.
Yeah, but the fact that Mypy is now just an optional static type system directly on Python could potentially enable those studies in a way that they couldn't before. Because even TypeScript has some non-trivial differences from JavaScript in addition to the static types. Whereas Mypy is really Python. I mean, when you run the code, you're just running normal Python, but you just have this additional static type layer.
So what does the future roadmap for Mypy look like?
So the first thing that's coming up here, which is something that I'm pretty excited about, is what we call strict none checking. And so this is kind of a work in progress feature that will hopefully come out in the next, say, month roughly. And basically what it does is it lets you specify in the type system if something can ever be none or not. And if you're trying to use, like, say, a variable that can be none, Mypy will warn you if you don't check for none before using it. And this basically gives you the tools to eliminate almost all none type errors, which I think is pretty exciting. So that's a kind of one of the last few larger changes to the type system that I think we'll see. And so for that reason, it's important to get in soon. And also, I think it just has pretty high potential.
Yeah, and that certainly, if you look at like it at Dropbox in production on our giant front-end web app, at the exceptions that get thrown, a large fraction of them are precisely this kind of bug, where it's an attribute error. Value of type none type has no attribute, whatever.
Right, because this thing can be set to none, and the difficulty with debugging these normally is they can be introduced at sort of many, many places in the code base. You don't know which of these many functions along the way returns none or assigns it to this attribute, and with this strict none checking, you'll also kind of get an error right there. If you have a function that can return none and you try to assign it to an attribute that's not allowed to be none, you'll just get an error right on that line, and you'll be able to say, aha, here's where something's going wrong. I need to check if this is none and do the appropriate thing. Or maybe the attribute actually does need to be none, but then Mypy will tell you every time you use it, if you're using it in a place where it really had better not be none, Mypy will make sure you've checked for it.
And you can also see this through the lens, again, of understanding the code better. That now you know not only like, oh, this is supposed to be a string and versus like an instance of this class I've defined over here, you'll actually know for sure, like, do I need to check this for none? Because it'll either be, and it's spelled optional of string, meaning that it's either string or none, or it'll be straight up string. And if it's straight up string, it cannot be none in any type check code.
So that's kind of, I guess, the first big thing on the horizon. We're also doing a bunch of perf work. We have a really big code base that we want to type check here, and so we're kind of making things faster. I think probably the most groundbreaking feature there is this incremental mode that we currently have in sort of like somewhat experimental stage, which basically caches the results after every run. And so if you just change one file and you rerun Mypy, it won't have to go and type check all of your other code, and so hopefully it should be able to be like really blazing fast. And kind of there's also there's still a fair amount of like kind of miscellaneous bugs and features that we're working on. Python has a lot of interesting behavior in various cases, and so that's basically going to be for the foreseeable future is going to be something that we're always going to improve. And so we definitely encourage people, if they use Mypy and they run into some issue, don't worry, post on the issue tracker and we will figure out what's going on and fix it. And I guess far down the line, we have some exciting things like editor integration and IDE-like features, so a great jump definition, or maybe some sort of refactoring support, find occurrences, things like that, or just saying, hey, what's the type of, highlight some expression in your editor and say, hey, give me the type of this. We think that's something that would be pretty exciting. And then also kind of far down the line, we want to have a sort of plugin system. So if you have, say, like a protobuf specification.
Or a Django model or a SQL Alchemy call.
Yeah,
that you'd want, for example, say you define a Django model, right? This is a thing that has a lot of structure. You go and define this class, it inherits from Django model, whatever, and you go and define, there's a particular way you define it, has some fields, some columns, and then when you go and have an instance of this, like a row from this model, it will have particular attributes and they'll have particular types, and that all comes in a very predictable way from the definition you gave to that class. But the relationship between that class definition and the types that you get on the instances is sort of a particular choice that's made in the Django implementation. It's not a thing, it would be very complicated to have the type system itself be rich enough in a general way to just sort of write that down in the type system. You could, when people like push really hard on type theory, they'll devise type systems where you can write all that stuff down. Like in Haskell, you could write down all kinds of stuff like that. But that's not, I think, the direction that makes sense for Python or a Python type system. And so what we expect to do instead is have a system for plugins where, corresponding to the sort of Django model itself, or SQL Alchemy, or protocol buffers, or other things that have this kind of like particular structured relationship that's distinctive between a definition somewhere and the types you get elsewhere, to correspondingly have sort of a type level definition of that. To have, well, there's the Django model like actual implementation, and there's some code that corresponds to that initially like we'd be writing the stuff, but in the long run, I think in a world with typing everywhere, the Django developers would have the Django Mypy plugin, and the SQL Alchemy developers have the SQL Alchemy Mypy plugin, and so on, which describes, okay, when the type checker sees a thing that is like inheriting from this base class or whatever, it goes and invokes this plugin, which is just this code that runs in the type checker that this is all very much on the drawing board. We haven't defined what this API will be, but some kind of API with the type checker to be able to describe what the resulting types are going to be from like looking at the definition of that class. And that I think will be really crucial for a lot of things that happen in many Python applications, including a Dropbox. We have certainly SQL Alchemy, certainly a protocol buffer, certainly some other things we have internally that are sort of ORM-like. We're going to very much want something along the lines of this kind of plugin system.
So are there any questions that we didn't ask that you think we should have, or any other topics that you'd like to bring up before we move on?
I think we covered it.
Yeah.
I would just say again, like we're very much at Dropbox excited about the the use of static types, and more of our code has static types on it. I was saying at PyCon just a few weeks ago that we had over 75,000 lines of annotated code. We're actually, I think, just about to break 100,000 lines, probably in the next few days. It keeps going up and up as, again, none of us on the Mypy team are doing this, but just a large number of other people at Dropbox are picking this up every day. And many people outside as well, including in open source projects like Zulip and Tornado and other companies. And I think I would encourage anybody listening to this to try it out and try using it on your code. And I think you'll like the results. And you can install it straight from pip. The package for historical reasons is called mypy-laying. So pip install mypy-laying in Python 3. And any kind of certainly bug you run into, any kind of feature request, anything you wish would do, any questions you have, please come to the issue tracker, github.com/python/mypy. And we're very responsive there and always love to hear from people.
Yeah, and Greg said it kind of quickly, but just to be clear, it's a Python 3 thing, so you better do like pip3 probably, or Python 3-m pip install mypy-laying.
Yeah, and just to underline, we said this earlier, but it works great on Python 2 code as well as Python 3 code. At Dropbox, it's almost all Python 2 code, and we're very happy with it. Mypy itself runs under Python 3 and then analyzes the Python 2 or 3 code.
Are there any areas that our listeners can help with that the project would appreciate contributions from?
Yeah, I mean, there's always a lot of work to be done. We have a number of kind of issues that are marked kind of difficulty easy. Easy doesn't mean easy, but it means easier at least.
Yeah, relatively good to do as the first thing you might do.
Yeah, definitely come talk to us first. We're always excited about new contributors. We have a IRC channel right now. We're thinking about switching to Gitter maybe.
Yeah, it's all described in right at the root of the repo on GitHub. There is a contributing file, so you can read there all about how to get involved. So anybody excited about getting involved, please take a look at that. Please talk to us. Any of those means. I think actually for most people, the best first step is just download and install it and start trying it on some of your own code. And I think generally you'll pretty quickly run into either questions about how it works or like more things you wish it would do or maybe even a bug. And that's a great hook to get started in getting involved.
Yeah, there's some interest in that on my team at work to get it running on some of our projects. And I'd also like to say that it's very great and forward-thinking of Dropbox to invest in the development of Mypy, understanding the returns that they're going to have in terms of developer efficiency.
Yeah, that's right. I feel exactly the same way. I'm very glad that we're doing it. And we have hundreds of engineers working in Python every day. So I think the returns are actually very, very strong for Dropbox and like very strong fundamental reasons why it's a good choice that Dropbox is doing this. But a lot of companies might not be that forward-thinking. I'm very glad that we're doing it.
So for anybody who wants to follow you guys in particular and keep in touch with what you're doing, what would be the best way for them to do that? David, how about you go first?
Follow me on GitHub, probably. I actually don't have that much of an online presence at the moment.
Not a problem. What's your GitHub username?
I'm DD Fisher, so 2 Ds and then Fisher like a fisherman.
Okay, great. And Greg, how about you?
Yeah, I have a pretty similar answer. I'm not a like active Twitter user or anything. You can find me certainly on GitHub at GN Price. That's GN as in November. You also, if you just do a Google search for my name, you'll find contact information and other things I've done. Find my webpage.
Great. So with that, I will move us on into the picks. My first pick this week is an episode of the podcast Functional Geekery, where he interviewed Andreas Stefik, and the subject that they discussed was actually the sort of history of formal studies about the various human factors of development, so things including ergonomics of programming languages and type systems and various other things like that. It was a very interesting episode, had a lot of really interesting pieces of information and references to different studies, so definitely worth taking a listen to, and seems particularly relevant to our discussion today. And another podcast that I started listening to recently is the Soft Skills Engineering podcast, and that's a couple of developers who have been longtime members of the Ruby Rogues podcast, and they started a show where they take listener questions having to do with various aspects of being a software engineer, and they do their best to answer the questions, and there's generally a decent amount of humor involved, so definitely worth taking a listen to. And I will pass it on to you, Chris.
Thanks. My first pick is a beer, unsurprisingly. It's from Grim Artisanal Ales. I've gushed about their beers before, and the most recent one that I tried is called Lucky Cloud. It's this really interesting kind of, it almost kind of looks like kind of goldish, but with this almost luminescent yellow tinge to it. Their beers are always very interesting in terms of color and shade, and they're also darn tasty. This one is a puckeringly sour, dry hopped beer with all these really interesting fruity sort of notes because of the hops that were used. I think it's New Zealand hops, I'm not sure, but really tasty stuff. Definitely check it out. My next pick is a tool. I've been editing a lot of JSON lately, and this thing makes it easy to slice it, dice it on the command line, syntax check it, parse it, you name it. It's called JQ, and if you're working in JSON frequently, you really should check it out. It's impressive stuff. And that's it for me. David, what do you have for us for picks?
So my first pick is a command line utility called FZF, which is a command line fuzzy finder. And I've actually gone through quite a large number of different fuzzy finders for accessing things through my editor and also just being able to quickly pull up files from a large repository in my terminal. And FZF has actually been by far the best that I've tried out of the quite large number. It's just really, really great to be able to just, if I know some file name and it's nested 5 directories deep in my project, I just start up FZF, type the file name, and boom, I'm right there. And I found that to be really, really huge. So that I've been very excited about.
I'll add, in fact, David got me using FZF a few months ago, and especially my editor, I'm very glad using it. It's very fast, and I just this week was making a change that involved like going to dozens of different files and making small fixes in them, and it was a lot faster than it would have been if I had to type out the entire names or like tab complete in the traditional way. And
it has editor integration for I think a bunch of different editors, so definitely recommend. My second pick is Thinking Fast and Slow by Daniel Kahneman. It's like a great exposition of human cognition, basically, and partly all the ways in which it breaks down, and it breaks down pretty badly, but also just kind of it's great as sort of a bit of an introspective book for understanding how I work. It's not really a self-help book. It doesn't really provide much hope per se, but it still gives a lot of interesting insight. And my last pick is another book, which is Ringworld by Larry Niven. It's a real sci-fi classic in my opinion. It's kind of I guess like an exploration story on massive, massive scale. And I think it does a really good job of conveying a sense of incredible scale, which I feel like I haven't got so much out of other books.
Yeah, I'll second your choice on that. The entire series of Ringworld novels are pretty incredible.
Yeah.
Thirded, and I think it's also a really interesting exploration of human behavior, strangely enough, given the alien landscape that the people find themselves in.
Cool. All right, so I have a couple picks for you. The first actually is an essay written by a mathematician named Bill Thurston, who was one of the greatest mathematicians of the 20th century. And it's called On Proof and Progress in Mathematics. It's sort of about mathematics, but it's really about how humans progress in learning things, how humanity progresses and humanity comes to know more and understand more, and how people communicate with each other as they learn more things and communicate those somehow to other people, and how there's such complex things often we have in our heads and how difficult it can be to convey those ways we have of thinking to other people. And so I think it's a really good reflection on all of that. And as a sort of special bonus, although he's a mathematician, it has some remarks about software specifically, which are surprisingly spot on, including, I'll just give a little teaser, he says that programming is harder than math to get right. So that's great. I encourage everybody to read it. It's only 17 pages long, and you can find it on the web. The other thing I recommend is a book, like several, I guess, a science fiction book by Greg Egan, who's an author in Australia, still active today. And what I especially like from Egan is the short stories. I'll recommend particularly his first collection called Axiomatic. And what runs through a lot of Egan's work, and particularly all the stories in Axiomatic, is sort of thinking about personal identity and memory and how that changes when people can be on computers, or when computers can be behaving like people, or where sort of technology starts getting intimately tied with our brains. And it has some really interesting reflections on it. I think Egan is one of the better thinkers we have writing about that. So Axiomatic, the first short story collection by Egan, is that.
Great. I really appreciate the both of you taking the time out of your day to join us and tell us all more about Mypy, and I definitely intend to take a closer look at it and start using it in more of my own projects. So thank you for that.
Cool. Thank you. Yeah, it's something that we're always super excited about, super excited to talk to people about, super excited for people to start using. So thanks.
Thanks, guys. Good night.
All right. Good night.